So we're going to learn about implicit differentiation. We're going to learn how to differentiate things that can't really be solved for x on their own. So we saw in the video or in the Desmos project how this works. We know that the derivative for this is negative x over y. But how does that happen? It's kind of crazy that we can somehow differentiate this and get negative x over y. So let's see how this works. So when we do differentiation, normally we would have something like y equals 4x squared, let's say. And in doing that, we have the dy dx, that's the derivative of y in terms of x. The derivative of y in terms of x is this function is in terms of x. We're taking derivatives in terms of x is equal to, and then we do the power rule, right? The power rule. So we wind up with 8x to the first. And then we're supposed to take the derivative of the inside, except this is x. So the derivative of x is actually dx because we're taking derivatives in terms of x here in this case. And dx is clearly 1. In fact, the derivative of x by itself is 1. But dx looks like a fraction, which it isn't really, but it looks like it. You can think of it that way in this case. So this is actually 1. You don't do this stuff. But what if we were taking the derivative of y squared over here? Then we would use this chain rule. Let's see what happens. So let's take the derivative of x squared. Oh, well, that's just like normal. That's going to be 2x. Let's take the derivative times dx if you want, but we're not going to do that because that's just 1. So derivative of x squared is 2x. We know that already. Now we have to take the derivative of y squared. Well, the derivative of y squared would be, well, 2y. If x squared is 2x, then the derivative of y squared is 2y. Except we have to follow the chain rule because y is not the function, is not the variable that we're taking the derivative with respect to. So the derivative of y, well, we said the derivative of y was dy dx. The derivative of y is dy dx, the change in y as x is changing. So this is the chain rule, and that's what creates our implicit differentiation. We're allowed to differentiate each term in our equation with respect to x. If x is our variable, fine, we don't have to worry about it. But if x is not our variable, we have to take the derivative of that inside variable as a chain rule with respect to x. All right, and then we need the derivative of 25. 25 is just a number. So the derivative of 25 is 0. Now, what we're looking for is the change in y as x changes. We're looking to solve for dy dx, which appears once in this equation. Now we use kind of algebra 2 skills or algebra 1 skills to solve for this unknown dy dx. So I'm going to subtract 2x from both sides. And we wind up with 2y dy dx equals negative 2x. Well, looks like we can divide by 2. In fact, we can divide by 2y. Let's divide by 2y. So we wind up getting dy dx, which is what we're looking for, is equal to negative 2x over 2y. Well, the 2's cancel and we wind up with negative x over y. Well, if you recall from doing the Desmos activities, that is in fact the derivative of a circle with a radius of 25. What would happen if the radius was different than that? As long as the circle is centered on 0, 0, won't this be the derivative of the circle always, as long as we have a point on the circle? Well, I think it will be. So we'll do some other examples, but that gets you started with the derivatives of implicit differentiation.